So angles in standard position allow us to describe angles that are greater than 90 degrees. Because if we're stuck in a triangle, we can't allow our angles to go beyond 90 degrees. However, in a circle, we can allow that angle to go beyond 90 degrees to 360 and in fact beyond 360. So standard position essentially is a circle that is centered at 0, 0, and the position of that dot tells us the location of the angle. Okay, so this dot here tells us the location of this angle. Okay, this angle and vice versa. So this angle tells us the location of this spot. The spot tells us the rotation of that angle. So the way we measure angles in standard position is in this direction we rotate, it's positive, so counterclockwise is positive. And if we go clockwise, we are going in the negative direction. Okay, so that's negative direction. This way is positive direction. And what we need to start kind of understanding that's different from regular trig is that the position of that point is the most important thing. That's why it's called standard position. The position is the most important piece of this, because that position allows us to describe angles that are from 0 to 90 and beyond 90. So that position is really important. So when we talk about positioning, the angle locates a position. Okay, so when I say 145 degrees, that angle is locating a position in this grid space. So 145 degrees is somewhere around here. So that point right there on the circle locates the position of positive 145 degrees. Okay, so that dot there, I'm going to highlight it, is the positioning of that angle. So that position and that angle now go together. Now, if you're wondering how trig falls into this, well, basically what happens is we can draw, there is a triangle that is associated with that position, and that triangle is defined by our x and our y position. So what about negative 70 degrees? So negative 70 degrees is going to rotate down from 0. So this is what we call our initial arm. That's always 0 degrees. Now we're going to rotate down 70 degrees, so somewhere about there. And so now that dot is the position that describes negative 70 degrees. So negative 70 degrees is the angle description of that position. That dot represents the location of that position, and that location of that position can be described with an x and y coordinate. Okay, so again, the position is the most important piece of this. So the standard position way to locate the position with two different ways. So we can locate the spot, that yellow dot, with an angle, or alternatively with an x and y coordinate. And between the two, we can translate, okay, between angle and xy coordinate, just like we translated between ratio and angle. Okay, so the x and y coordinate is related to ratio. So we're going to say here this is related to ratio. Okay, so when we look at this and when we define these positions, we're going to define these positions in the xy space. And the x and y coordinates is going to locate that position. So here, 150 degrees. I'm going to go start again at 0. I'm going to rotate 150 degrees to somewhere about there. Okay, and that position is the position that goes with the angle, the standard position angle of 150 degrees. Okay, and that position has some x and y coordinate associated with this. Okay, so there's some x and y coordinate related to that position. Negative 210 degrees is going to go in the opposite direction. Okay, so here's our 0 degrees again. The negative 210 is going to go 90, 180, and an extra 30 degrees, and it's going to locate that position. In fact, those two angles happen to locate the exact same spot. Okay, so these are what we call coterminal angles. These two angles are in fact the same thing. Okay, when we do the trig on these, the trig is all the same. So if you want to test it on your calculator, you can. You can do cosine of 150 degrees and cosine of negative 210. You will get the exact same answer because the cosine relates to the positioning. In fact, it relates to the horizontal positioning. And the horizontal positioning is the same for both of those angles. So this positional angle describes the position as an angle. These x and y coordinates would describe the same position of that angle. And this is how we start transitioning from triangle trig to positional trig. We're going to just redefine this as the sine goes with the y, so our sine is vertical, and the y position replaces our opposite side of the right triangle. The x goes with horizontal, so the x replaces the adjacent side of our triangle trig. And y over x becomes our slope, okay, and that one's easy because that's always been slope. So we are then going to use this x and y positioning now to be able to go beyond this triangle and to start describing angles, not just in quadrant 1, but quadrant 2, quadrant 3, quadrant 4. And if you've never heard of these quadrants, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And we can now describe angles beyond 90 degrees, and we could do trig on those angles beyond 90 degrees.